Good morning. Today we are going to fit a line to a bunch of data and then write an equation for that line as well. So I'm going to write an equation for it. So what these lines are fitting to, it says just a bunch of data, is what's really a scatter plot. So a scatter plot is a bunch of random points that are plotted on an x and y axis on a graph. So a scatter plot is a graph used to determine whether there is a relationship between paired data. Scatter plots can show trends in data. So if y is increasing as x is increasing, meaning they're both going up, the paired data are said to have a positive correlation. Now the word correlation is another word for a slope. These have a positive slope. If our slope man was going to walk across this graph from left to right, it would be walking up. Same thing over here. All of this data generally is pointing in a downward direction. If we walked across this from left to right, it would be going down, or a negative correlation, or a negative slope. But this last one is just a bunch of random points. There's not a nice way to put a line through this data, so we say that this graph has no correlation, or relatively no correlation. So when we are drawing lines through a bunch of data, they try and put the line as close to all the points as possible, with some above the line and some below the line. An easy way to make sure that you have some points above and some points below is to first circle all of the points. And then draw a line, oops, that was not a good line. Draw a line through the circle to form a nice straight line to make sure some are above and some are below. We'll get to that a little bit later. Right now, they just want us to describe the correlation of the data graphed in the scatter plot. Describe the correlation or describe the slope. So this one, looking at it from left to right, would be a positive correlation. And this one, from left to right, would be going down, or a negative correlation. So that goes back to when we talked about slope. But now, it says using the scatter plots above, predict a reasonable test score for 4.5 hours of study. So this one's talking about test scores. However many hours you study would predict a good or bad test score. And then the second one is talking about the more hours you watch TV, your test score is really going down or going negative. So first, predict or use this graph to guess or get really close to a reasonable test score if you're going to study for 4.5 hours. So these go by ones, 1, 2, 3, 4, 5, 6, 7, 8, 9. So hours of studying, 4.5 would be right here between 4 and 5. So what we're going to do is we're going to follow this to our line. Whenever we hit the line, we're going to look over and predict our test score. So these go by tens here, 50, 60, 70, 80. So it's a little bit more than 70. I would say maybe 72. Maybe you're thinking, Miss Calc, maybe it's only 71. Maybe you're going to predict 75. You think it's right in the middle. All of these are okay answers. You only need to write one answer though. Okay? Same thing over here. We're going to predict what's a good test score, or what's a reasonable test score if you're going to study for 4.5 hours, or watch TV for 4.5 hours. So again, 4.5 is right here in the middle. If we follow that up to our line, once we hit the line, look over. Again, we're between 70 and 80, but to me this one's a little bit higher, maybe like 77. Maybe you're thinking, maybe it's more really close, maybe it's 79. But you only need to pick one number, you don't need to list more than one. So now we have a line, and we need to write an equation of this line. Now there are a couple ways we could do this. Well, most likely they had a bunch of other points and a scatter plot, and they put a line through this data. Before we get to all of that, we're just going to first start off by reviewing how to write an equation of the line in the form y equals mx plus b. Well, we know how to find our slope. We have 2 points right here. Let's just start with what we know. So let's count our slope. Rise over run. We're really going down -1, 2, 3, 4, 5, 6. And over 1, 2. Well, 6 divided by 2 is 3, and it's negative. So our slope is -3. And then we need to find B, our y-intercept. So right now, we have 2 points. We could use one point or the other point. It doesn't matter which one. I'm going to use this point as x and y, and I'm going to use my slope to write an equation so I can find my b. This is what we did earlier in this chapter when we plugged in x and y and our slope to find our b, our y-intercept. So y right here is 5. Our slope is -3 times x, which is 4, and then plus b. So if I solve this, -3 times 4 is -12. And we want to get b all by itself, so I'm going to add 12 to the other side. 5 plus 12 is 17. So my equation would be y equals m, which is -3x, plus b, which is 17. Which makes sense. This goes till about 10. If this graph were to continue, we'd cross the y-axis at about 17. Now some of you might be thinking, well, I didn't want to use this equation. What if I want to use this equation? And that is perfectly okay. If you use this equation instead, thinking you have a point and a slope, and you want to use point-slope form, let's see if we get the same answer. This would be my x1 and y1, and my slope. So we'd have y minus y1, which is 5, our slope, which is -3, and then x minus x1, which is 4. Let's see if we get the same answer we did over here. Well, let's distribute. -3 times x is -3x. -3 times -4 is a +12. And get y by itself, we're going to add 5. We have y equals -3x plus 17. So here, this one I plugged it into point-slope form and got y equals -3x plus 17. And this one, I plugged it into slope-intercept form and found b because I already knew what my slope was, slope and intercept, and I wrote it in slope-intercept form. Either one will get you the same answer. Hopefully this is information that we learned earlier this chapter. Now we're going to use that to do a little bit more. This slide is just talking about the steps that we're going to take. First, we're going to make a scatter plot, or a bunch of dots. We're going to plot a bunch of points. Then we're going to decide whether it can be modeled by a line. Can you put a line through it or not? Are they just too random that it's not going to make sense? Then we're going to draw a line that appears to fit the data closely. Like I said, we're going to circle it and put a line through it, or just make sure there's the same amount above and below. And that's exactly what it says here. There should be approximately as many points above the line as below it. And then we're going to write an equation using 2 points on the line. We're trying to get this equation, y equals mx plus b. The points do not have to represent actual data pairs, but they must lie on the line of best fit. What I mean by that is if you have these points and you put a line through it, and you need 2 points to find your slope, and let's say there aren't any on here, well, let's say maybe that one's on there, you can say, wow, that goes through the origin, or this would be a really nice point to use to help us. So we can actually use another point even though we didn't plot that point, as long as it's on the line. It must lie on the line. So once we have that, just like we did earlier, we're going to find our slope. We're going to count rise over run, and then find our y-intercept and write an equation. So let's go through that process right now. Step 1, make a scatter plot. I already did that. And I decide whether it can be modeled by a line. I already put the line through it. If you want, you can say this is a positive correlation. You don't have to, though, because it didn't ask for it. Draw a line that appears to fit the data closely. I already did that for you on this one. Now we need to write an equation in the form y equals mx plus b by finding the slope and the y-intercept. So first we need to find the slope. Now, none of these points are actually on this line. This one is pretty close. If we can't find any other better points, I would maybe use that point. But we want to find 2 points that are at the intersection or counting by ones, whole numbers. So I would say instead of that point, I think this point would be a better point to use because I can count to it really easily. This point would be xy, it would be 3, comma, and down 1, -1. And as I look along my line, not super close. What about way at the end right here? This point would also go through a nice intersection or counting by whole numbers. X would be -3, and y would be down -1, 2, 3, 4, 5, 6. So using those 2 points, I'm going to count my slope. I'm rising 1, 2, 3, 4, 5. And I'm going to run 1, 2, 3, 4, 5, 6. So notice, I'm only using the 2 points that I found that are on the line. I don't really care anymore about all the rest of the points. So all of these points, I don't care about. I'm going to ignore this point, 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 because I only care now about the line. I only use the points to draw the equation of the line or draw the line. But I already did that for you on this one. So now we have our slope, m. We need to find b, our y-intercept. Well, we can see that it's crossing somewhere between -3 and -4, right there. But I'm not entirely quite sure what that is, so I need to figure it out. I am going to use point-slope form. If you would like to instead use y equals mx plus b, you may. I showed both methods on the first slide. Oops, x plus b. So you can really use either one. I'm going to use this point as x and y. So it says y minus y1, which is -1. That makes a positive. Our slope is 5/6. And then x minus x1, which is 3. So just like we've been doing for the last few days, let's distribute. 5/6 times x is 5/6x. And then 5/6 times -3. That's really -3 over 1. So 5 times -3 is -15. 6 times 1 is 6. And that's not going to be a nice number. And that's okay, because you know what? This line might not cross at a nice number. Doesn't look like it does. So -15 divided by 6 in my calculator is going to give me -2.5. And over here I have y plus 1. And then I want y by itself, so I'm going to subtract 1. So we have y equals 5/6x. And -2.5 minus 1, they're all negatives. That gives us a -3.5. This is in the form y equals mx plus b. And let's check. -3.5? Well, that makes sense. It's between -3 and -4. Let's try this same process again. And if you want here, you can put -3.5. We found out what b is. We're going to try the same thing on the next slide. Alright, just like the last one, it says make a scatter plot. I could have plotted these points, x, y, or 0, 2, thinking 0 up 2. To save a little time, I plotted them for you. But you know how to plot points 1, 3.5. X is 1 to the right, up 1, 2, 3.5. I already plotted those for you and drew a line of best fit with some points above and some points below. So it says describe the correlation of the data. From left to right, remember correlation means slope. This is a positive correlation. If possible, fit a line to the data. We did that. Now we need to write an equation of the line. Our equation needs to be in the form y equals mx plus b. So first let's find our slope, m. We need to look for 2 points that are on the line. Well, now, none of the blue points that are there are on the line, so we need to pick our own points. So pick 2 points. This one's a little tricky. I'm going to say this point right here is close enough. And that point in terms of x and y, x is 1 to the right, and y is up 1, 2, 3. And then looking for another point, I'm going to say, wow, this is tough. I'm going to say maybe this one's close enough as well. It might not always be perfect, but you can get kind of close. And this one, x is 3 to the right, and y is up 4. Remember, our points are always in alphabetical order. So let's find our slope. Reminder, we don't care about any of those other blue points now. We only care about the two that are on the line. So my slope is rise 1 and run 1, 2. My slope is 1/2. Now I need to find b, or my y-intercept. So you can use this equation, picking a point and a slope and plugging it in for y, x, and m. Or you can use y minus y1 equals our slope, x minus x1. The only benefit to this one is you don't have to rewrite it when you're done. So that's why I like using this one. If you want to use this formula, you can. It's maybe easier to remember. So I'm going to use this point because they're smaller numbers. So it's y minus y1, which is 3, equal to our slope, right here was 1/2, and then x minus x1, which is 1. So distributing 1/2 times x is just 1/2 x. 1/2 times negative 1 is negative 1/2. And then we want y by itself, so we need to get rid of that 3, add 3. So we have y equals 1/2 x. Now we have a positive 3 and a negative 1/2. If we have 3 and we take away only half of one number, we're left with 2 and a half left. So there's our equation. Let's check. Does b at 2.5 make sense? 1, 2.5. Yep, that would make sense. So there's our equation in the form y equals mx plus b. Here's another one, but this time we actually have to make the scatter plot ourselves. So let's plot our points x, y. I'm going to put our numbers on here so that we can see where we're plotting. Oops, negative 2. So first, this point is negative 2, 2, x, y. Negative 2 to the left, and then y is up 2. Our next point is negative 1, 1. So negative 1, up 1. Our next point is negative 1, 0. So negative 1, we didn't go up or down right there. Our next point is 0, negative 1. So we didn't go left and right. X is 0, y is down 1. Our next point is 1, negative 2. So x is 1 to the right. Negative 2 is down 2. And then our last point is 2, negative 3. So x is 2, y is down 3. So these form a pretty straight line. Now there are a couple ways, like I said, you could draw your line. You could just try and put a line through, some above, some below, maybe somewhere like that. Or, if you'd like, instead, you could circle the points. Oops, that was not very good. You can do a better job of circling the points. And then putting a line through your circle. Either way, you should get about the same line. Now, for the sake of just this problem, I'm going to say pick the same points I pick. So first, it says describe the correlation. This from left to right is going down, so it's a negative correlation. We already fit a line to it, but now we just need our equation in the form y equals mx plus b. So like I was saying, we need to first find our slope, so we need to pick 2 points that are on the line. We don't care about those red dots anymore. We only want to pick 2 that are on the line. Now this one, to me, looks like it goes right through there. So I'm actually going to use that point, which was negative 2, 2. And then I'm also going to use, that one's not on the line, not on the line. Pretty close. This one's not as close, not as close. So I'm going to maybe use this point. And that point right there is x is 0 and y is negative 1. So this time I happen to pick 2 points that were already plotted. You do not always have to do that. You can pick your own points. So, finding our slope first. You could plug in y2 minus y1, x2 minus x1. I'm just going to count -1, -2, -3, rise over run. Oops, not 2, -3. And running 1, 2. -3 over 2 would be my slope. And then I need to find b, my y-intercept. I know I have a point and a slope. Doesn't matter which point I use. I like this point 0, -1 because we have a 0. It's easy to add 0. So our equation is going to be y minus y1 equals our slope, x minus x1. I'm using point slope form because I have a point, x and y, and a slope. So y minus y1, which is -1, makes a positive, equal to our slope, which is m, -3 over 2, and then x minus x1, which is 0. So if we solve this, distribute, -3/2 times x is just -3 over 2. -3 over 2 times 0 is just 0. And over here we have y plus 1. So we want to get y by itself, subtract 1. Our equation would be y equals -3 over 2x, and 0 minus 1 is -1. So this equation is what we're looking for. And this one we could have actually looked for 0, comma b, but we are following this procedure. But yes, this would have worked as well. All right, one of our last problems. Describe the correlation of the data graphed in the scatter plot, and what does it mean? So, first, describing our data, I'm going to actually draw a line through this, some above, some below, so that I can see a trend to follow. So this one, going from left to right, is a negative correlation. This one from left to right would be a positive correlation. And I did those lines pretty quick, but you need to make sure that there are some above and some below. It might even go through a couple points like that one. And then, what does this mean? So, this is going down. What's going down? Well, the rabbits are going down as our snow depth, how deep the snow is, goes up. So, rabbit population and snow depth. So we can say, as the snow, because the rabbits per square mile is going to depend on how much snow there is. If there's a lot of snow, it makes sense that there's not going to be a lot of rabbits because they're not going to be able to survive. So as the amount of snow increases or goes up, the number of rabbits, well, what happens? As the snow gets deeper, the number of rabbits is going down or decreases. Same thing over here. And we always start by looking at x. If this happens, if x happens, then y. If the number of rabbits goes up, because here we're going up, the number of hawks is also going up, because the hawks are going to hunt the rabbits. So we can say, as the number of rabbits increases, the number of hawks also increases or goes up. And that makes sense. Our last problem, this is one I would like for you to try on your own, and then click play to see if you got it right before you start your homework. It's the same as we've done before. Make a scatter plot, describe the correlation, and then write an equation of the line. So first, let's make our scatter plot. This is x, and this is y. So our first point, 1, 9. So x is 1, y is 9. So 1, 9 would be right there. Then 2, 7. X is 2, y is 7. Then 2 up 6, right below it there. Then 3, 4, 1, 2, 3, 1, 2, 3, 4. 3, 3, so 3 to the right, up 3. 4 to the right, up 3. 4 to the right, up 2. And you should have plotted these already. Tried it on your own first. And then 5 to the right, up 1. So there's our scatter plot. Describe the correlation. If I put a line through here, some above, some below, I'm going to maybe say, maybe about like that. I would say that from left to right, our slope is negative. Our correlation is a negative correlation. And then we need to write a line of best fit. So our equation is going to be in the form y equals mx plus b. So let's first find our slope. In order to find our slope, we need 2 points that are on the line. So, well, this point actually goes through really nicely through that point. So that point is 1, 9. And this one, it's over here, so it doesn't really go through that point. This one, nope, close, but not quite. I would say it probably goes through this point as well. So from here to here, this point is 4, 2. I'm going to find my slope, rise over run. I'm really going down negative 1, 2, 3, 4, 5, 6, 7, and over 1, 2, 3. So there's my slope. I need to write an equation. I'm going to use this form. Again, you could use this one and solve for b as well. And it doesn't matter which point you use. I'm going to use this one, 4, 2, as x and y. x1, y1. So y minus y1, which is 2, equals our slope, which is negative 7/3. And then x minus x1, which is 4. So let's solve. Now, if you picked 2 different points, you would get an equation that's really close to my answer. But there's lots of different lines we could have drawn through here, so we're all going to have different equations, and that's okay. You're not going to have the exact same answer I do. So on your answer key, a lot of it's going to say answers will vary. So if you get the exact same answer as your answer key, I'm going to assume that you either had the same points as them every single time, which is very unlikely, or that you just copied the answer key. So make sure to write your own line and create or find your own points, okay? So back here we're distributing. Negative 7/3 times x is negative 7/3 x. Negative 7/3 times negative 4 now. Negative 7 times negative 4 is 28. 28 divided by 3. That's going to give me my calculator about 9.3 repeating, or 9 1/3, whichever you would like to write. It's a positive. I'm just going to write 9.3. It doesn't matter. It's the same thing. Oops, not y equals y minus 2. And then to get y by itself, we need to add 2. So we have y equals negative 7/3 x plus 11.3 repeating. And that makes sense. 9, 10, 11.3, it would cross it about there. That makes sense. Your homework is a worksheet. Make sure to follow the directions. These first 3, it just says tell whether they show a positive, negative, or no correlation. So you need to just write a word for those ones. These are the ones where you actually have to write an equation on these and on the next few. The last 2, you're just interpreting the graph, describing the correlation, and then predicting a point like we did right here. So good luck and show your work.